Welcome back to this channel. In this video, we are going to be discussing the mole mass volume relationship. It is our second series on stoichiometry video. Now you see, these concepts are quite a little different from the former ones we did because there is a sort of advancement now. We have brought in the third quantity that we use in in chemistry rather, which is the volume. Now, I want you to understand a little bit of formulas first. Now, when we combine these formulas, we have different derived quantities. For example, when we combine mole and volume using division, we have concentration. Is that okay? So we have mole, which is represented by N, is equal to mole is N and volume is V. Is that okay? Volume is denoted by V. Is that okay? So now concentration, there are two types of concentration. We have a molar concentration and a mass concentration. So when we have a mass concentration, it's going to be what? Mass conc. Is that okay? Mass concentration is going to be in grams or mass per volume. That is mass concentration. Now it is similar to density in physics. Is that okay? That's mass concentration. And molar concentration in standard solution is given as molarity. Is that okay? You see 2 molar. 2 molar means 2 moles per dm cube. So it means mole over what? Over what? Volume. Is that okay? Now, one thing that students also find hard in understanding volume is the units. Is that okay? The unit of conversion. All right. From our basic knowledge of mathematics, we already know some of the units of conversion. We have 10 millimeter makes 10 centimeter and 10 centimeters. So we have that 10 centimeters make 1 decimeter. Is that okay? So let's just use 1 dm. And 10 decimeters, 10 dm make what? 1 meter. Is that okay? So how do we now convert from centimeter cube to decimeter cube? And since we already established the fact that 10 centimeters make 1 dm cube, it means that 1 cm cube times 1 cm cube, you know that volume is equal to length by breadth by height, isn't it? So we have that 1 centimeter cube by 1 centimeter cube by 1 centimeter cube will equal to what? 1 times 1 times 1, that is 1. I mean 1 centimeter times 1 centimeter times 1 centimeter. 1 times 1 times 1 is equal to what? 1. 1 and centimeter times centimeter times centimeter, that's what? Centimeter cube. Is that okay? Good. So from here, we can also say that 10 centimeter times 10 centimeter times 10 centimeter is equal to what? 10 times 10 times 10 is what? 1,000, isn't it? And cm times cm times 10 times cm is equal to everything. All right. Cm times cm times cm is what? 1,000 cm cube, isn't it? So that we now have 10 centimeter here is equal to what? 1 dm, isn't it? Another 10 centimeter is what? 1 dm. Another 10 centimeter is what? 1 dm. So what do we have here? 1 times 1 times 1 is what? 1 decimeter. 1 times 1 times 1 is 1. Then dm times dm times dm, that's what? 1 dm cube. So what does this tell you? This tells you that this guy is equal to this, isn't it? So 1,000 centimeter cube is equal to what? 1 dm cube. So this is the unit of conversion. So if I told you I had 20 cm cube and you are told to convert to decimeter, now you don't have to stress yourself at all by beginning to think, am I going to multiply by 1,000 or will I divide by 1,000? It's no stress at all. Just use this unit of conversion and you get your answer. For example, to convert this to dm cube, now I know because I already know how to solve it that I should divide by 1,000. But if you don't know, what you can do is this. Write your standard unit, which is 1,000 cm cube is equal to 1 dm cube. So you now say, therefore, 120 cm cube. The one mistake you shouldn't make is to put this guy here and put dm cube here, because dm cube is in this side, cm cube is on this side, so you arrange them accordingly. Then you basically what? Cross multiply. So that you have what? 1,000 cm cube times x is equal to 20 cm cube times 1 dm cube. So you divide both sides by 1,000 cm cube. This takes care of this 1,000 cm cube. So cm cube takes care of cm cube, isn't it? So that we now have this, and we have what? 0.02 dm cube. Do you understand that? All right. So this is how you convert from decimeter to centimeter. Now, how do we now solve? Now, there are some constants. There are some constants we should already know here. In this case here, there are some constants we should know. We are going to be dealing with gases first. We're going to be dealing with gases. So the major gas constant that you should know first here is the constant as standard temperature and pressure, STP. STP means standard temperature and pressure. Is that okay? At STP. Now, standard temperature is what? 273 Kelvin. And pressure is what? 1.01 times 10 to the power 5 or 760 millimeter mercury, 1 atm, etc. There are many units like that for pressure. All right, so, but at STP, at standard temperature and pressure, it has been observed that 1 mole of gas always occupies. Now, this is what people don't get. They don't usually know how to wrap their head around this. It's very simple. 1 mole of gas, the quantity in volume of 1 mole of gas is equal to, occupies 22.4 dm3. Let me explain what that means. This means that if I have 1 mole in quantity of gas, in volume, it is equal to 22.4 dm3. Let me re-explain that practically. If I have a jar or a cylinder where I have gases, and it's calibrated, this is the 100 centimeter mark. It means that 100 centimeter cube mark, which is one, for example, which is 100 centimeter cube. If I have 1 mole of gas here, 1 mole of gas inside this jar, it's sealed, of course, so that the gas will not escape. Now, if I have 1 mole of gas here, this will mean that I have around here 22.4 dm cube. If it's 100 dm cube, 100 dm cube. It means that I will have around here 22.4 dm cube of what? Of gas. Do you understand? Because around here will be 25. So, and we have 50 will be around here. So something around that. You understand? So 1 mole of gas means what? 22.4 dm cube of gas. Is that okay? So, and that is how to go about this question. Now, how do we solve questions? How do we solve questions in mole, mass, volume relationship of gas? Now, the first thing to do is to write a balanced chemical reaction. Now, if you don't write a balanced chemical reaction, you are very likely to fail that question. Is that okay? So, for example, you are given something like this. The reaction, the EVA process, for example, and you are writing something like this, N2 plus H2 gas to give NH3 ammonia. Now, this is not a balanced reaction yet, so you have to balance this. You are 3 here, you are 2 here, I think. So, and this is now balanced, okay? We know the catalyst is iron, isn't it? So, but we are not particular about even the catalyst yet. In this case, we first identify the ratio of their relationship. How do we identify the ratio of their relationship? Now, you check here, you ask yourself here, what is the ratio of their combination here? The way you check ratio of their relationship is by mole and by volume. Is that okay? By mole and by volume. Now, looking at this equation, this is the balanced chemical reaction of this equation. Now, since I have attained a balanced chemical reaction, I now check what is their mole relationship. How many moles of nitrogen do we have here? We have 1 mole ratio. How many mole of hydrogen do we have here? We have 3 moles. Is that okay? And how many mole of ammonia are we producing? We are producing 2 moles of nitrogen. Now, this can also be interpreted to its volume. So that since this is the ratio of their combination, if I started with 10 centimeter cube of nitrogen, if I start with 10 centimeter cubes of nitrogen, in order to produce by standard, I will require 30 centimeter cube of hydrogen to react to this. And what will be produced eventually will be what? 20 centimeter cubes of what? Ammonia. So that is the ratio of their combination. You need to really understand this. Now, if I react, for example, if I react hydrogen H2 plus Cl2 to produce HCl, all right, and I just put 2 here. What is the ratio of their combination in this reaction as well? We have 1 ratio 2. So meaning that if I started with 50 centimeter cube of this, I will need 50 centimeter cube of this also to produce what? 100 centimeter cube of this. This is not additive. This is basically according to their ratios. Definitely, if I started with what? Here, for example, if I started with 40 cm cube of this, it means that I'll need triple portion of this, isn't it? I need 120 centimeter cube of this to produce me what? Double portion of this, which was 80 what centimeter cube. Do you now understand? All right. So understanding the mole volume relationship will help you to attempt questions. Now let's go into solving some questions using these rules. Now we're going to be adopting the rule of equating the for the conversion. We are going to be adopting the rule of equating those relationships, this constant. All right, so let me write some questions on the board now, and we're going to be solving them. Let's attempt these 4 questions, and I want you to adopt the same technique that I'll be adopting in this video to solving these questions. I want you to adopt the technique when you'll be solving your own questions as well. We have CO2 plus this guy to produce C plus O2 to produce CO2, isn't it? So the question now says that how many moles of pure carbon will burn in 2.8 dm cube of oxygen completely at STP? Now, this is a very important term that you have to take note of. So all you have to do first is to write their mole of the ratio of their combination, the mole ratio of their combination. We have 1 mole requires 1 mole to produce what? 1 mole, isn't it? So what does that mean? It means that 2.8 dm cube that is being given here is going to produce what? 2.8 dm cube of this guy, isn't it? But we're not even particular about this guy now. What we need is what? How many dm cube will this guy, how many dm cube rather, how many moles rather of this carbon will be required? How many moles of this carbon will be required? So what do we do? What do we do? Now, this by standard, since it is at STP, since it is 1 mole requires 1 mole to give 1 mole, all right? You now say that 1 mole first, 1 mole of gas is equal to what? 22.4 dm cube. Is that okay? So it means that 1 mole is equal to 22.4 dm cube. So how many mole is this 2.8 dm cube? That's what you want to check. This 2.8 dm cube represents how many mole? Since 1 mole is 22.4 dm cube, you now say how many mole is this 22.8 dm cube? So it means that that is the number of moles of carbon that is also reacting because their mole ratio is 1:1:1. Is that okay? So we convert this to mole. So let's convert this to mole. We're going to have this dm cube. So we cross multiply and we have what? We have x, we have 22.4 x. So I'm going to eyeball the units because, of course, we are going to get the same answer. We're going to know the units that we'll get as our answer. So we have is equal to 2.8 times 1. All right. So you divide both sides by 22.4 over 22.4. So this takes care of this. And I have x equal to 2.8 divided by 22.4. 2.8 divided by 22.4. And that gives me 0.12. That is 0.125 moles of what? 0.125 moles of what? Of this gas. Is that okay? Since their mole ratio of combination is 1:1:1, it means that if 0.25 mole of oxygen is required, then 0.25 mole of carbon is also required. And we are done with that question. All right, let's go to question 2. Question 2 says that that's 1b. It now says what will be the volume of carbon dioxide produced under the same conditions? What will be the volume? It's very simple. What will be the volume of carbon dioxide? Since it is 1:1:1, definitely it means that 2.8 dm cube, which is the starting material is going to give us the same 2.8 dm cube of what? CO2. And that is the answer. All right. And then someone will now begin to ask, what is the volume of the carbon? Now, we don't take volume of solids. We only take volume of gases. We only take volume of... What will be the volume of this guy that will be produced under the same condition? So it's basically what? 2.8 dm cube. Why? Because that's the mole ratio of combination is 1:1:1. And since these are the only 2 gases there, so it means that the volume of this guy that will produce also what? 2.8 dm cube. Now, the next question says, calculate the volume of H2S required to completely react with 11.2 dm cube of this guy in this reaction. So let's write the reaction and see first if it is balanced. 2H2S plus SO2 to give 2H2O plus 3S. All right. So with this, we have that it is balanced. O is 2, O is 2, S is 3. All right, so this is balanced. Now, and we are given that the molar volume of gas is 22.4 dm cube. So it now says that the amount of H2S required to completely react with this amount. So first, let's take the ratio of combination. So 2:1 ratio. Now this liquid, you could eyeball it, you could write it if you want, and the other guy is a solid, so you don't even necessarily need to write that. So, but the ratio of their combination is that two quantities, that is 2 degrees, or just a 2 quantity of this guy requires 1 quantity of this guy to react completely, isn't it? So what do we say? If it therefore means that if we are starting with 11.2 dm cube of this guy, how many volume? What is the amount in volume of this guy that we need? It means that we need what? 2 times this, 2 times of this. Is that okay? Because this one is one quantity of this, 2 quantities of this and 1 quantity of this is reacting. So it means that if we are starting with 11.2 dm cube, we'll be needing double of that for this guy. So that what? 22.4 dm cube. So honestly, you don't want to solve this question. All right. Okay, it now says what is the amount? Since the amount is in moles in this case, calculate the amount in moles. So since this is a gas, how many moles contain 22.4 dm cube? It's 1 mole. So the answer is what? 1 mole. And that's the answer. You don't even need to solve. Is that okay? All right. So the next question says that number 4 question says, now this one we are giving more units. We are giving more units to calculate with, more quantities rather to calculate with. So we have, okay, no, that's question 3 now. Question 3. Question 3 says that magnesium of mass 1.2 reacts completely with chlorine according to the reaction below, according to this reaction, right? So we have Mg reacts with Cl2 to give MgCl2. So what do we have here? It says that we should now calculate the volume of chlorine used. So since 1.2 grams of sodium is reacting with, of magnesium rather, is reacting with this guy, what is the volume of chlorine that is used? What you necessarily have to do is just ask yourself how many moles of magnesium is reacting there. The mole ratio is 1:1 to produce what? 1. Is that okay? So it means that, and we have 1.2 grams here. So how many moles is that 1.2? We know that 1 mole of this guy is what? 24 grams per mole, isn't it? 24 grams per mole. So this guy occupies 24 grams. How many mole is that 1.2 grams? That's what you ask yourself. So you now cross multiply, and you're going to have x to be equal to this divided by this. So 12 will be half, that will be 0.05. 0.05. If this is, that will be 0.05. 1.2 divided by 24 is 0.05. Now this is 0.05 moles. So it means that 0.05 moles of this reacts with 0.05 moles of this to produce 0.05 moles of that. But now we're also calculating volume, right, of chlorine that is used. And we know that 1 mole at STP of chlorine is equal to 22.4 dm cube. So how many moles will, no, how much volume will 0.05 moles occupy? Notice I always write the same unit at, on the same side. So I cross multiply, x will be equal to 0.05 times that guy. So 0.05 times 22.4 dm cube, and that gives you what? 1.12 dm cube. And that is our answer. And that's how simple that one is. All right, let's go to the last question. The last question says, calculate the mass of bleaching powder that will produce 4 centimeter cube of chlorine at 25 degrees Celsius and a pressure of this. All right, so we'll write the units, the items we were given. All right, in fact, the chemical reaction here is not shown. The chemical reaction is not shown. Calculate the mass of bleaching powder that will produce 400 centimeter cube of chlorine at this. So we just write the parameters that are given. Now this is the equation for the reaction. All right, so let's write the parameters that are given. Now let's see if this equation is balanced. In fact, two hydrogen, 2 chlorine, and 2 chlorine, 2 chlorine, 2 chlorine, 1 calcium. Okay, I think it's balanced. So let's write the parameters that are given. We have 400 centimeter cube. That will be V1. So V1 is equal to what? 400 cm cube of chlorine at this temperature. So we are going to have T1 to be equal to what? 25. Now we'll convert that to Kelvin scale, so that will be this plus this, and that will give us 298 Kelvin. Then and the pressure of this, so that will be P1 equals 1.2 by 10 to the 5th Newton per meter squared. And okay, so that's what we have. So the equation, the reaction is occurring at standard temperature and pressure. So we have standard temperature for T2, that will be 273 Kelvin, and standard pressure for what's it called? Standard pressure for at STP, that will be P2 is 1.01 by 10 to the what? 5th power. That's what we have here. And so I'm eyeballing the units. Is that okay? So what we are looking for essentially is what? V2, isn't it? So what do we do here? We recall that the ideal gas equation, nRT is equal to what? PV over T. So what does this tell you? That for a constant disk, we'll have P1 V1 equal to P2 V2. P1 V1, that's nR is equal to this, in fact, not nRT. P1 V1 over T1 is equal to P2 V2 over T2. So what do we have? P1 is given by 1.2 by 10 to the 5th by, now since we are looking for V2, I'll just manipulate the equation and form the V2 equation. So V2 will be equal to what? Here, V2 will be equal to what? We equal to P1 V1 T2 over what? T1 and P2, isn't it? All right, so what do we do here? We basically bring in our values. V2 will be equal to, what is P1? 1.2 by 10 raised to the power 5. You can talk. What is V1? 400 centimeter cube. So just 400 times, what is T2? 273 Kelvin all over. What is T1? 298 by, what is P2? 1.01 by 10 to the 5th. All right, so this can take care of this. Then we can use calculator for the rest. So we are going to have 1.2 times 400 times 273 is equal to V2 equal to 131040 all over 298 times 1.01. This will give you 300.98. All right, so let's divide that. We have V2 will be equal to 131040 divided by 300.98. So we have 435 points. 435 points what? 38. Is that okay? 38 centimeters cubed. Now, the question, so we've gotten V2. The question now says that at STP, we should calculate the mass of bleaching powder that will produce this. Is that okay? Now, at STP, this is the volume of chlorine that will be produced at STP. So let's calculate the mass of, since the ratio of combination is one mole of this guy is going to produce 1 mole of this guy. So it means that the amount of volume of this guy, the amount of volume of this guy that will produce, the amount of volume will be the same. That's what I'm trying to say. The ratio of combination is 1:1. So the amount of volume that will produce this guy is the amount of volume that this guy is starting with. The amount of volume that is produced here will be the amount of volume that this guy is starting with. So since at STP, we have that we are calculating in mass now, the mass of bleaching powder. So you say that 4. Okay, we're supposed to calculate. Let's calculate the RMM first of bleaching powder. What is the RMM of bleaching powder? We have Ca, which is calcium, which is 40. We have RMM of CaOCl2. So we have 40 plus O, which is 60, plus Cl2, which is 35.5. So we have that times 2 give us what? 71, isn't it? So add this all together. 127 grams per mole. Now, we have that when 127 grams per mole reacts, we have 1 mole of this. Is that okay? So it means that when we have 127 grams per mole to react, that is 1 mole. 1 mole of this is provided. And what is 1 mole of this? 22.4 dm cube. Or you say in centimeter cube, basically multiply by 1000. And that will be, but if we just want to use, let's use dm cube so that we'll convert this one to dm cube. Is that okay? So I don't confuse some people. So I have 127 grams, we produce 1 mole, and 1 mole is 22.4 dm cube. So how many grams will produce this amount? Is that okay at STP? So we're going to divide this by 1000. If you divide by 1000, you get 0.43538. Is that okay? So we are going to machine this to cross multiply, isn't it? So that we have 22.4x is equal to 0.43538 by 127. Now, divide both sides by 22.4 over 22.4. So let's bring it here. We're going to have x will be equal to, what is the top there? 2.468. The top? Or everything all together? Oh, okay. So x, so it means that our x is equal to what? 2.468. So in 3SF, 3 significant figures, we're going to have 2.47 grams. Is that okay? And this makes sense. Why? Because if 127 grams is reacting to produce 22.4 dm cube, and so how many grams will produce this less? It's going to be a lesser gram. Is that okay? So this brings us to the end of this video. If you did get value, make sure you subscribe to the channel and share the content with some of your friends that might need the video. See you in the next one. God bless you.